5 times 5 is?
25.
Yeah. Hey folks, welcome out there. Hey, Tuesday afternoon? I believe it is. We've had a great day yesterday. We've had a great day today here around the studio. Some of you had a little earthquake. We had one here. We felt it about 3.4 on the Richter scale they set up in Maynardville, Tennessee, rumbling a little bit. So, we're safe and secure here. We're watching Mathline, right? And what we need you to do, I'm Ernie Roberts, the host for the afternoon session. And what we need you to do is give us that call, 844-686-2378. What can you do? Hey, call us, talk to us. We will work your problems live here on the air. Now, we had some good calls yesterday, some good problems waiting in the wings just in case. But you know what? We prefer to hear from you guys because when you call in, you make the show rock. And we want it to rock. We want it to rock, 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 rock. Yes, please give us a call, all right? 844-686-2378. And to get you thinking a little bit, before we do that, I want to introduce, we have phone operators today from the Bearden High School Key Club. We want to make sure they get busy, all right? There's Malachi and Haley, and we're glad to have them. They've been here before. They are waiting to talk with you and help you through this process of getting to talk to me, all right? And we're all friendly about it, but give us a call, all right? 844-686-2378. Now, let's go to problem of the day. Problem of the day starts off with some question here. It says, what type of triangle is formed on the coordinate plane, that means we're on graph, using the points 5, 0, -5, 0, and 4, 3. Those are 3 points. They obviously are going to make a triangle. How can we be sure? Oh my goodness, that means we got to not just take a guess at it. We're going to have to come up with some reason to show why it works. So again, we've got 3 points. Y'all go ahead and graph them at home. And we're going to see if we can figure out how do we make this thing work? How do we get what type of triangle it is, all right? And let's play with it a little bit. So the first thing we're going to do is start off with, we are going to graph. And we'll go ahead in just a second here. We'll graph those points on a piece of paper. Graph points. And that way, once we graph the points, we got an idea. What does it look like? I mean, it may be totally obvious it's an obtuse scalene triangle, all right? It may be not so obvious that it's an obtuse scalene triangle. Could be a right triangle, could be acute, could be isosceles, could be equilateral. We're going to play with it and see what happens. So if y'all give me just a second here, let's get a piece of graph paper up here. So we're going to graph the points first. And let me get my paper here. See if I can flip it up. There we go. And let's see what's happening here, all right? We've got the numbers. We have 5, 0, which is on the x-axis, by the way. Make sure you don't put it on the wrong axis. There we are. And we've also got -5, 0. So we're going to go back to the left, 5 units, and there's -5, 0. So that tells me right there, that's one of the sides of the triangle, okay? And that's easy to count. That's easy to count blocks. That's a good thing. You may not need it, but it's easy to count if you need to. Now, the next one is we're going to go over 4 and up 3. Now, be sure we do that in the right order, because we're going to go over, that's from the origin, by the way, 4 to the right and up 3. Now, we are going to need to connect a little bit here. So let's do some connecting, because we're going to form a triangle. And that will give us hopefully a better idea of what we think it might be. And then we'll play with the information and see how we need to go about figuring out for real. As we draw this together, there we have it. And we'll go ahead and put one right down here because it sort of looks like the line is extending. And there we have it. So I'm seeing what looks like it could be a right triangle. Looks like it. Now, remember what I said, we need to figure out how is it going to be a right triangle. And since we're on a grid, we've got some help. We've got some assistance here. What we can do is figure out the slopes of these line segments, or these sides, if you will. Now remember, this point out here is what? -5, 0. This one is 5, 0. And this is 4, 3. Okay? So let's play the slope. Slope game. What slope? Everybody got it? Rise over run. So let's see what we have. And first of all, let's find this slope. By the way, why are we going to look for slopes? I guess we need to point that out too. If we can find opposite reciprocals, in these two numbers, we have a right angle. We have perpendicular lines which form a right angle. So let's play it out and see what happens. First of all, I'm going to, we could do the formula. I'm going to put first line, we'll call it this little segment right here. We do the formula, or we can just, hey, we're on a grid. We can just count blocks, all right? What's our rise going from here to here? Well, it looks like, actually, we're dropping, aren't we? So we're really not rising, we're going lower, but that would give us a -3 for our rise. And then we went out 1. So once again, know how I did it. There we go, 1, 2, 3 down, and out 1. So it looks like our slope for the first line segment here, this little guy here, is -3. Now, you say opposite reciprocal, Ernie, what does that mean? What that means is I want something positive for this, and I would like for it to be the reciprocal of 3/1, which of course would be 1/3. So let's again go back and figure out the rise and run business here. So we're going to look at our grid, and we've got it going up 1, 2, 3. This time I'm going positive. And I'm going to the right. Oh my goodness, a lot of blocks. Let's write down that 3 before we start counting blocks. So we go up 3 to about right there, and then we cross over 1, 2, 3, 4, 5, 6, 7, 8, 9. And we ask ourselves, ooh, are those exactly opposite reciprocals? Well, if you reduce 3/9, here you go. Fraction action again, fraction action. Let's reduce that down. We will come up with 1/3. Notice they are opposite reciprocals of each other. Wow. Did you expect that one? And there we have our right angle. So we're not going to worry about, obviously it's scalene, right? That one's pretty small. This one is a little bit larger, actually quite a bit larger. And then this thing is really big. The hypotenuse would be the largest, longest of all 3 sides here. So it is scalene, and it is a right triangle. So in answer to the question, there we go. How do we prove it? Go for the slopes. Go for the slopes is the easy way. Now, there's another alternative, and if we have some time in the show, I'll come back to this problem again and give you another alternative using the distance formula, being able to find all 3 distance formula pieces here. In other words, find the lengths by using the distance formula 1, 2, 3 times, and then one big last time, we'll take each side, a squared plus b squared, and see if it gives us c squared, all right? A little Pythagorean theorem, and that's what it is. That's how we'll check it out, all right? But that's another option. That's another thing. So in the meantime, let's go ahead and get some calls going out there. It'll be at 844-686-2378. We want to hear from you. Yesterday, I have to say, Sammy, I did not get to call you back at the end of the show. I think you called in. Give us another call, all right? We'll talk with you today. Somehow the phone numbers got a little jumbled or whatever, and we did not have the right number to get back to you. So I apologize for that. But we do want to hear from you again. I understood you called back in after you gave us a good problem at the beginning, all right? So we want to hear from you again. Folks, anybody, any ages, we'd love to hear from you when you call in for us here. So 844-686-2378. Now, we just talked a little bit about a right triangle situation, so let's take a little bit more of a look here, all right? I'm going to bring in a problem for us here, just a second, and let's take a look at this one here. This is a rectangle situation, and you say, why do I worry about a right triangle with a rectangle? Well, let's see. Because first of all, rectangles have right angles, and we are going to be looking for a couple of things, actually 3, count them, 1, 2, 3 things off this problem. So let's create a little rectangle here. Y'all can do this at home too. And we've got we'll call it length about 8 here. And let's bring it down here a little bit. We'll create maybe a little bit longer. Pull it across here. And it looks like I'm going a little downhill, so let's see if I can straighten that up a little. And we'll pull it down here. Boom, there's our rectangle for what you may like of it. We'll put some right angles on it because that's what goes on there with rectangles. Folks, a rectangle is a parallelogram with 4 right angles. And it makes it very special, very spectacular. And here it says we're going to find the area, perimeter, and the diagonal length. Now we've got 6 here, we've got 8 there. We've got it here also, don't we? 8 and 6, because parallelograms have opposite sides congruent while they're also running parallel. Ooh, little lesson, all sorts of geometry going on here. So let's do this. We need to find a diagonal. We also find the area, also perimeter. So right now, you can find area and perimeter pretty easily. Actually, dear friends, you can find that diagonal length pretty easily. Remember I mentioned something in our opening problem of the day all about a right triangle there? So here's the first thing we can do. We can look at right triangle here or right triangle there. By the way, does it matter which diagonal I draw in? Absolutely not. They're both going to be the same. That's a property of rectangles. The diagonals will be congruent, which means they have the same length. When we figure out what one is, we have the other. That's nice, isn't it? Don't have to worry about anything else. So let's play it out here. It looks like a right triangle shaping up for us here. And for that, let's go to our good old friend, the Pythagorean theorem. A squared plus b squared equals to c squared, all right? And putting in the numbers, what does A and B stand for? A stands for a leg, B stands for a leg, C will be our diagonal. You know, so I could just make that C become a nice sweet little OD right there. So A squared plus B squared equals, this time, D squared, diagonal squared. So let's go after that. Let's make that a better looking D. Let's put some numbers in here. How about it? Let's put in 6 squared. Let's put in 8 squared. And that is going to give us D squared out of that, all right? Take 6 squared, we've got 36 rocking for us here. 8 squared, I'm seeing 64. And on the other end of the piece, we still don't quite yet know what we've got, but we will. We will pretty soon. So let's bring it right over here and add those two together. 36 and 64. Some people say, can you do that in your head? I hope you can. It's simply going to give us 100. And 100 equaling to our D squared. Now that's nice. Gave you a perfect square. Sometimes I do that, sometimes I don't. But we're going to let it go as a perfect square because that's what it is. And we're going to square root both sides here. We're going to take a square root both sides through here. And you're going to get a possibility of 10, or you could get negative 10. But let's understand why we can't use plus or minus 10 on this answer. We're talking about a length. Lengths are always positive. So we're going to go with the 10 for the diagonal. So there's check that one off. Now the next piece of information says let's find the perimeter. Now this one's not so bad. This is not so difficult. Perimeter, basically what are we going to do? The perimeter by formula is 2 times the length plus 2 times the width. Or you could just say we're going to add all those numbers together. But let's play it with the 2 times and adding then, all right? Let's see. First of all, we'll put 2 times, how about 8 going in there? And we'll have 2 times 6. Life looks pretty good, doesn't it? I see perimeter equaling 16 plus 12, which we can add together very nicely and give us 28. Now, keep in mind, I didn't give you units on these, but this perimeter will be in whatever units we've got here. There's no square inches going yet, all right? The square inches are going to come from our next little creature here. So we'll just say units here, all right? 28 units. And let's see what happens with the area. Area equals length times W, length times width. And we know what those numbers are. So we put in 8, we'll put in times 6. Can't go wrong on those two numbers. They're very easy to work with. No halving. Now if we were wanting the triangles, we would be taking half, all right? But we're looking for the whole rectangle, all right? So whole big rectangle. And that's going to give us 48. We'll use square units because that's what area is about. So there you have the 3 ingredients. By the way, this would be in whatever the units are. This is no squaring with the diagonal. There it is. And why is there no squaring? Because we took care of the D squared and reversed that process. So we're back down to inches, feet, yards, whatever you happen to use for your units. Over here, the perimeter stays as units because we're not multiplying anything out except doubling pieces. But when we double, we're not changing from units to square units. And then last but not least, the area is where you do put the square units. So that's a nice little warm-up piece there. Hopefully you're ready to warm up a little more to us this afternoon, all right? It's cold outside, I know that. 844-686-2378. This is what we want to do. We want to hear from you. And, you know, people have been asking, you see more geometry? Well, you just got to see a little geometry problem right there. And I understand we do have a Hey Math line waiting in the wings, right? Let's check and see what we got here.
Hey Math Line, I'm Elizabeth from Carter High School in Knoxville, Tennessee. Will you please solve the equation 5 minus 3x equals 35 for me?
All right, Elizabeth, Carter High School here in Knoxville, Tennessee. Great to hear from you on that. Great to meet you up at Ripley's Aquarium this past summer. We have quite a few people that have stopped by and did some problems for us, and we get to look at those along the way here. She said, would we like to solve the equation 5 minus 3x equals 35? I'd love to solve it. And in fact, I'm going to go one step further. We're going to check it also. How's about? We'll check our solution when we get there. So let's see what we've got here. Let's work through this little problem. It says 5 minus 3x equals 35. And as I said, I just feel it's very important, and I keep emphasizing that on this show and with our callers and everybody. We always want to check to see, did we do it right? Did we get the answer that makes this equation become a true statement? Because that's what you're looking for. You're looking for x. And in the meantime, while we're working on this one, folks, go ahead and give us that call, all right? That number 686-2378 with an 844 in front of it, all right? So take care of us on that business. Let's take a look at 5 minus 3x. Write it down at home if you already haven't done it. And we will work it out, see where it's going to go. First things first, the whole goal is to do what? Get the x by itself. So here comes a little bit of algebra, but it's not a really tough piece. But this minus sometimes throws people for a loop. The minus is not attached to the 5. Well, it is, so to speak, but it's not in front of it. What matters is this is a positive 5, all right? This minus is really attached to the 3x because that's what we're subtracting. So it only connects the 5 and the 3x. So first things first, don't do 5 minus 3. That's not right. No, no, no. This 5 is its own little entity right there. The 3x is its own entity, so to speak. And then 35 is hanging out by itself over there. So this was a positive 5. Remember I said that. So we're going to subtract 5 from both sides. That's called our subtraction property of equality there, all right? That means whatever we subtract from both sides, we do the same thing. Now, don't lose your negative. Sometimes when I have students work a problem like this in class, or on a test, even worse, they forget to bring that minus down. It's kind of like, oh, it disappeared, didn't it? No, 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 no. So keep that going with you. And now over here we have 30. All right, life is good. Elizabeth, hang on for me. We're going to get through this thing. We're going to divide now both sides by the negative 3. And that should give you x equals, well, that's easy, isn't it? We can divide negative 3 into 30. What's your sign? It's going to be a negative 10 according to our calculations. Quick check. Time to check, right? And this one is one you can do mentally. But we're going to do it physically. How about that? We've got 5 minus 3x equals 35. Let me caution everybody. Go back to the original equation when you check, because you might have made a mistake right off the bat. You don't want to make a mistake. The whole idea of checking is to make sure you don't make any mistakes. So put that negative 10 in there, 3 times negative 10, equaling to 35. What happens when you multiply first, right? Do not say, don't do 5 minus 3 first. Multiply. That's what goes first. My dear Aunt Sally tells us to do that, and that's how we check. We're going to have 5 plus our 30, and you know what? I believe that's going to give us 35. It does, and life is good. Good answer. Elizabeth, thank you from Carter High School at the Aquarium. And Ripley's, thank you for letting us come up and have some fun this summer. And we'd love to come out to some of your schools and some of your businesses, some of your places, and have a little math line time where we can shoot some Hey Math lines with you guys. So don't forget that. In the meantime, give us a call, 844-686-2378. Understand, I have a caller waiting in the wings. Welcome to Math Line this afternoon. Who am I talking with?
This is Caitlin.
Caitlin, how are you doing today?
I'm doing well. How are you?
Great. Fine here, too. Where are you calling from?
I'm calling from Talbot, Tennessee.
Talbot, Tennessee. Great. Great to have you with us this afternoon. What kind of problem you've got for me?
Okay, so a child dropped a marble.
Mm-hmm.
Okay, from a bridge 120 meters high.
Okay, hold on. Dropping a marble. And you're at the top of a bridge, right?
Yes.
120 meters high?
Yes, sir.
Okay, sounds good.
All right, how long did it take for the marble to reach the water?
How long did it take for the marble to reach the water? Okay.
Yes.
So in other words, we're looking for, it's starting at 120, but we're going to end up where? At 0, right?
I'm assuming. It doesn't really tell me. It's a word
Well,
problem.
that's what happens. When you hit the water, you're going to be at 0, all right? So you start at 120. Now, I'm going to need you to look and see, is this Algebra 1 or Algebra 2 type problem here?
I'm not exactly sure.
Well, are you in Algebra 1 class or Algebra 2 right now?
I'm in Algebra 1.
Okay, so you're doing an Algebra 1 type problem. So what we're needing to do here, there's an equation for the effect of gravity coming on there, and I need you to give me that equation, all right? Do you have that in a textbook or in notes or something that would give me an idea of what's going on? It's a distance and it's a formula. Because that's what we're doing, is we're going to replace 120 with a certain point, and we're going to set it equal to 0, okay? So you're kind of at this high point. I think we're going to try to make a parabola look, okay, from the situation.
All
but
right.
if you can look and see if there's an equation that goes along with it, or a formula, is what I should say.
I think I have it. I think it's
Okay.
D equals
Okay.
D equals 1/2
Okay.
G, and then you have T squared.
All right, you got, all right, D equals 1/2 of T squared.
No, D equals 1/2, and then you have a G, which is gravity, which is 9.81.
Okay.
And
all
then
right.
T squared.
All right, so let's do this. So we've got this distance equals 1/2, and the gravity is what, 9.81, you say?
Yes, sir.
And we're going to square that, or we're going to have T squared attached to it? Is attached to T squared, right? Am I good now?
Yes.
So we're going to take half of 9.81 and then worry about T squared. And we know that D is how much? 120. Does that make sense so far, what we're doing?
Yes.
Okay, because that's why I say usually when they give you a problem like this, they're not expecting you to just come up with the formula out of midair. They usually give it to you, and especially when you said you were in Algebra 1, I figured that's probably what's going on there. So let's go ahead. I'm going to hit the calculator just a second, all right? I'm going to hit 1/2, which is 0.5, or 5/10, times my 9.81. Because I want to see what that gives us. All right, and that looks like it's going to be about, looks like almost 4.9 on the money. We'll go ahead and put the 0.05 on there with it, okay? So 905 thousandths there times T squared. So far, so good?
Uh-huh.
Now, what we want to do is get T by itself. This is just typical what you do with algebra. So let's divide this thing by 4.905 and see what happens. And definitely, I'm going to go to the calculator on this one. All right.
Okay.
I don't think we all want to do that. If it were just dividing by 4, we could move that almost to 5. That would be, you know, we could get idea pretty close. But let's see where we are. So let's see. We're going to divide, aren't we? So I hit the right. I need to hit the right key there, my dear. Let's see. 4.905. Let's see where this takes us. Should be interesting. Ooh, it almost gets us to, almost gets us to 5 or 25 there. I was thinking it would be nice if it would come out even, but it's okay. So what we've got here is, looks like 24 and about 40. I'm going to take it to the nearest hundredth, okay? And maybe 46.5 thousandths will do. That's a decimal. Equaling to T squared. So far, so good?
Mm-hmm.
Now, let's simply take and figure out what the square root of that value is. And I believe we're going to go with second. We'll take square root, and I'll put, since we're cutting it off just a little bit, 24, and I said 465. It's going to be close to 5. For all practical purposes, it's going to take you about 5 seconds to do that, all right? But does that make sense to you?
Yes.
T equals, and so we go back here, we square root both sides. So we've got T equals, like I said, is about, looks like about 4.95, which is very close to 5, approximately 5 seconds. Give it just shy of 5 seconds. And in this timing, I doubt the rock's going to know the difference, or the marble there. Does that make sense to you?
No.
You follow what we got here?
Thank you.
Let me go back one more step here. We went to here, right? 1/2, 9.81 was what we decided was our constant there that we're going to use, and then T squared. So just want to make sure we're good on the constant. Okay? All right. Hey, thanks for calling in on that. It's a great challenge problem there for us there. Folks, that's Algebra 1 nowadays. Some of you are going like, I don't remember doing that in Algebra 1. But it's a good application, a little kind of almost like a physics problem thrown in with the math that's oriented there. And given a formula, there's so many things we can do. Just like we did with the area, did the perimeter, those are great things. And remember I said something about the slopes earlier? Those are formulas too. So formulas are so important, and they work. They work. They get us where we want to go there. So again, thank you, folks. I want to thank our Bearden High School folks out there. They're staying. I understand the phones are ringing still, so let's take a look there. Yeah, they were working hard there. There's Elijah and Haley. Thank you from the Bearden High Key Club. We had from Elizabeth, from Carter, and also our final caller from Talbot, Tennessee. We sure do appreciate them. And you know what? We appreciate you all tuning in this afternoon. 844-686-2378, that's our number. And if you didn't get around to us today, we're here for a little bit, usually after the show. And you can always get us again tomorrow, because we'll be back live. Friday, we do have a specialized segments, but also we want to tell you, Facebook, check us out there. You always can get a head start on the problem of the day. And how about it? The other one, YouTube. You can see it if you miss us, all right? And you can watch our specialized segments in their entirety. So those are important little things to remind you. And again, thank you, Bearden High School Key Club, for being with us today. Thank you for tuning in, everybody out there. It is Mathline. It's been a great afternoon. And again, we will see you again next time.